Skip to content. MacTutor logo. MacTutor. Home. Biographies. History topics. Map. Curves. Search. Alan Matheson Turing. Quick info. Born June 23, 1912. London, England. Died June 7, 1954. Wilmslow, Cheshire, England. Summary. Alan Turing's work was fundamental in the theoretical foundations of computer science. Thumbnail of Alan Turing. View 7 larger pictures. Biography. Alan Turing was born at Paddington, London. His father, Julius Matheson Turing, was a British member of the Indian Civil Service, and he was often abroad. Alan's mother, Ethel Sarah Stoney, was the daughter of the chief engineer of the Madras Railways, and Alan's parents had met and married in India. When Alan was about 1 year old, his mother rejoined her husband in India, leaving Alan in England with friends of the family. Alan was sent to school, but did not seem to be obtaining any benefit, so he was removed from the school after a few months. Next he was sent to Hazelhurst Preparatory School, where he seemed to be an average to good pupil in most subjects, but was greatly taken up with following his own ideas. He became interested in chess while at this school, and he also joined the debating society. He completed his common entrance examination in 1926 and then went to Sherborne School. Now 1926 was the year of the general strike, and when the strike was in progress, Turing cycled 60 miles to the school from his home. Not too demanding a task for Turing, who later was to become a fine athlete of almost Olympic standard. He found it very difficult to fit into what was expected at this public school, yet his mother had been so determined that he should have a public school education. Many of the most original thinkers have found conventional schooling an almost incomprehensible process, and this seems to have been the case for Turing. His genius drove him in his own directions rather than those required by his teachers. He was criticized for his handwriting, struggled at English, and even in mathematics he was too interested with his own ideas to produce solutions to problems using the methods taught by his teachers. Despite producing unconventional answers, Turing did win almost every possible mathematics prize while at Sherborne. In chemistry, a subject which had interested him from a very early age, he carried out experiments following his own agenda which did not please his teacher. Turing's headmaster wrote, see for example, 6. If he is to stay at public school, he must aim at becoming educated. If he is to be solely a scientific specialist, he is wasting his time at a public school. This says far more about the school system that Turing was being subjected to than it does about Turing himself. However, Turing learnt deep mathematics while at school, although his teachers were probably not aware of the studies he was making on his own. He read Einstein's papers on relativity, and he also read about quantum mechanics in Eddington's The Nature of the Physical World. An event which was to greatly affect Turing throughout his life took place in 1928. He formed a close friendship with Christopher Morcom, a pupil in the year above him at school, and the two worked together on scientific ideas. Perhaps for the first time, Turing was able to find someone with whom he could share his thoughts and ideas. However, Morcom died in February 1930, and the experience was a shattering one to Turing. He had a premonition of Morcom's death at the very instant that he was taken ill and felt that this was something beyond what science could explain. He wrote later, see for example, 6. It is not difficult to explain these things away, but, I wonder. Despite the difficult school years, Turing entered King's College, Cambridge, in 1931 to study mathematics. This was not achieved without difficulty. Turing sat the scholarship examinations in 1929 and won an exhibition, but not a scholarship. Not satisfied with this performance, he took the examinations again in the following year, this time winning a scholarship. In many ways, Cambridge was a much easier place for unconventional people like Turing than school had been. He was now much more able to explore his own ideas, and he read Russell's Introduction to Mathematical Philosophy in 1933. At about the same time he read von Neumann's 1932 text on quantum mechanics, a subject he returned to a number of times throughout his life. The year 1933 saw the beginnings of Turing's interest in mathematical logic. He read a paper to the Moral Science Club at Cambridge in December of that year, of which the following minute was recorded. See for example, 6-am Turing read a paper on mathematics and logic. He suggested that a purely logistic view of mathematics was inadequate, and that mathematical propositions possessed a variety of interpretations, of which the logistic was merely one. Of course, 1933 was also the year of Hitler's rise in Germany and of an anti-war movement in Britain. Turing joined the anti-war movement, but he did not drift towards Marxism, nor pacifism, as happened to many. Turing graduated in 1934. Then, in the spring of 1935, he attended Max Neumann's advanced course on the foundations of mathematics. This course studied Gödel's incompleteness results and Hilbert's question on decidability. In one sense, decidability was a simple question, namely, given a mathematical proposition, could one find an algorithm which would decide if the proposition was true or false? For many propositions it was easy to find such an algorithm. The real difficulty arose in proving that for certain propositions no such algorithm existed. When given an algorithm to solve a problem, it was clear that it was indeed an algorithm, yet there was no definition of an algorithm which was rigorous enough to allow one to prove that none existed. Turing began to work on these ideas. Turing was elected a Fellow of King's College, Cambridge, in 1935 for a dissertation on the Gaussian error function, which proved fundamental results on probability theory, namely the central limit theorem. Although the central limit theorem had recently been discovered. Quick search anywhere. Enter words, phrases, DOI, keywords, authors, etc. Search. Go. Logo. Skip main navigation. All journals. Skip main navigation. Journal menu. Close drawer menu. Biographical memoirs of Fellows of the Royal Society. More sections. You have access. Obituary. Alan Matheson Turing, 1912 to 1954. Maxwell Herman Alexander Newman. Published, 01 November 1955. https://doi.org/10.1098/rsbm.1955.0019. Abstract. The sudden death of Alan Turing on June 7, 1954 deprived mathematics and science of a great original mind at the height of its power. After some years of scientific indecision, since the end of the war, Turing had found, in his chemical theory of growth and form, a theme that gave the fullest scope for his rare combination of abilities, as a mathematical analyst with a flair for machine computing, and a natural philosopher full of bold original ideas. The preliminary report of 1952, and the account that will appear posthumously, describe only his first rough sketch of this theory, and the unfulfilled design must remain a painful reminder of the loss that his early death has caused to science. Alan Matheson Turing was born in London on June 23, 1912, the son of Julius Matheson Turing, of the Indian Civil Service, and of Ethel Sarah Turing, née Stoney. The name Turing is of Scottish, perhaps ultimately of Norman origin, the final G being an addition made by Sir William Turing, of Aberdeenshire, in the reign of James VI and I. The Stoneys, an English-Irish family of Yorkshire origin, produced some distinguished physicists and engineers in the 19th century, 3 of whom became Fellows of the Society, and Edith A. Stoney was one of the early women equal to Wranglers at Cambridge, bracketed with 17th Wrangler, 1893. Alan Turing's interest in science began early and never wavered. Both at his preparatory schools and later at Sherborne, which he entered in 1926, the contrast between his absorbed interest in science and mathematics, and his indifference to Latin and English subjects perplexed and distressed his teachers, bent on giving him a well-balanced education. Footnotes. This text was harvested from a scanned image of the original document using optical character recognition, OCR, software. As such, it may contain errors. Please contact the Royal Society if you find an error you would like to see corrected. Mathematical notations produced through INFDI OCR. View full text, download PDF. Back. Biographical memoirs. About this publication. Memoirs in progress. Contact information. Purchasing information.